Right, this is our first example on limits with regards to trigonometric functions. Okay, so what do we do here? The first thing is we check, okay, are we getting the indeterminate form? So here already we can see it's division by 0. There we get 0. Okay, so here we already know we're getting this form 0 over 0. We want to avoid that. So how do we avoid it? We avoid it by usually we avoid it by getting rid of what was giving us division by 0. But in this case, we won't be able to go far if we did that. Okay, so what are we going to do? What we'll do now is that we are going to recall this function that we had looked at in the previous video. Okay, we said that limit of this as it approaches 0 is 1. So we'll try and create it here. Okay, so now the problem that we have is that we have this 5 inside here, so we can't just get rid of it. So we have to form something like this, where we have 5 and then we have 5x there. So how can we do it? Here it will be impossible. This is inside the function. You can't just change the contents of the function, but you can change these because these are not bounded by anything. So we can go in and do something like this. We still maintain our limit. Here I'm going to, if I wanted to make 3x as 5x, what do? I can multiply by 5 over 3. Okay, so that these cancel, then I get 5x. Then I get 5x. Okay, so here I can do 5 over 3, right? Then I maintain my sine 5x. Then I divide by 5 over 3. Then I multiply by 3x. So I can go with my limit. The x approaches 0. This and this can go. And then this remains. Okay, so this can now become 5 over 3, like that. Then we have this one here, which is sine 5x, but then this 5 now can come and work with x. So I've got 5x here, and I've got 5x here. So we say that if this is the same as the contents of the function, then, and then we're approaching 0, then we can get what? We can get 1. So we can say now, this is going to be, it's going to give us 1 here, and then we can say that this is now equal to 5 over 3, okay, times 1. So this is going to be 5 over 3, like that. So that's the limit. Okay, let's test another one. So what about this one? Okay, this is well, the same. We check what we check for our strategies. Are we getting the indeterminate form? So we check what is cos x from what we just saw, cos x. If we put 0 cos x from trigonometry, we said that this is 1, actually, not 0. So if it's 1 minus 1, then we will get division by 0, and then we'll get the indeterminate form. All right, so here we have to get rid of what's causing this. And so we have to get rid of this whole thing. Okay, so how do we get rid of it? We begin by remembering our identities that we can apply here. So one of the identities that we can remember is for the double angles, right? So this one was 2 cos squared x minus 1. And then we say that this same one can be 1 minus 2 sine squared x. But we can already see that will not help us if we went with sine. So this is the one that we go with, right? So we write the same one. Okay. And then here we're going to say that we are going to change this to 2 cos squared x minus 1. And then we take away 1. So we have a situation like this now. Right? So now we are going to see that we have this limit as well. And then once we expand this, we're going to see that we will have 2 cos squared x. Then minus 1 and minus 1 gives us minus 2. And then we have cos x minus 1. Now you remember here we have this, right? We can factorize 2, okay? And then we'll have cos squared x minus 1, like that. then we maintain our cos x minus 1, and then we'll still maintain our target limit there. All right, so now this we can tell that it's difference of two squares. So we'll say limit 2, and then we'll have the difference of two squares here. Right, okay, so this and this can cancel out. Then our limit, you don't have to write all this all the time. You can work it out, then apply a limit, and you say this is equal to that. It's still fine. Okay, so now here we are going to say that we have this one. As long as you remember what you're doing, and then you can, okay, so we don't have any divisor now. So if we check here, if we applied 0, it actually works. Okay, it actually works, because now we are saying that there's no, we got rid of this issue that we had. So now we can say that this, if we applied 0 there, we can have 2, and then cos, because we are applying 0, so now that limit has to go. So we can say cos 0 plus 1. Okay, so now this is going to be 2, and then we have 1 plus 1. And so this is equal to 4, because this is 2, right? So this is how we should be looking at this. We have to connect concepts from different areas. So you see here, we had to remember the application of double angle. We had to remember the difference of two squares. So everything comes together when it comes to calculus. All right, all the best, and try to forward if you can, and then also remember, if you can join the channel, that will help. All the best.